Hi, my name is Julia, and today we're going to be going over a 4th grade lesson on how to solve for area and perimeter. More specifically, we're learning how to measure the inside and the outside of rectangles and how to solve for area and perimeter when we're missing some of the information, like missing side lengths. We're going to be using these skills to solve real-world problems related to area and perimeter. We're going to be doing this by working through a few examples together, and we're going to also be incorporating our counting block manipulatives, and we're also going to be incorporating our grid paper. So first, let's start by going over some definitions and vocabulary that's going to be used within the lesson. So we have area, perimeter, length, width, and dimension. So area is the total amount of space inside a two-dimensional shape. Perimeter is the total distance around the outside of a two-dimensional shape. Length is how long a shape is or how long something is. Width is how wide something is or how wide the shape is. Dimension is going to be the measurement of the shape, such as the length and the width. And then down here we also have the formula for area, and we have the formula for perimeter. So the formula for area is area equals length times width, and then the formula for perimeter is perimeter equals 2 times the length plus 2 times the width. Let's go ahead and let's get into it using our grid paper and our connecting block manipulatives. So to find area, we know area equals length times width, but we're going to use the visual. So I'm going to instruct my students to make a rectangle that is 5 blocks long and 3 blocks wide. So let's go ahead and do this. We're also going to fill in the whole shape because area is what is inside the shape. All right, and once I've done that, we're going to go ahead and physically count so we can see how many blocks there are in total. So we have 3, 6, 9, 12, and 15. I can visually see here that the area of my rectangle is 15. I can also clearly see that the width is 3 and the length is 5. 5 times 3 is 15. But let's go ahead and let's do this by plugging our values of the lengths and the width into our formula. So if area equals length times width, our length is 5 and our width is 3. 5 times 3 is 15. We know this is true because we just put all the connecting block manipulatives down. We physically counted them all, but now we can also plug in the values of the side lengths and put them into our formula, and we can double check that it in fact does equal, the area equals 15. So now let's do this if we're going with a word problem where we're missing some side lengths. So I'm going to read the problem aloud. What is the area of a patio with unknown width and a length of 40? The perimeter is 98. So we know our perimeter is 98. So I'm going to put that over here in the corner. I'm going to draw our patio. So let's see. And we know that we're looking for area. So we're going to put everything inside the shape. We know the length is 40. So the length isn't just strictly, well, the length is 40, but we have 2 side lengths, right, for 40. So we have 40 and 40. We don't know what these are. Question. So how we're going to find what the lengths of our width is, or what the values of our width are, is by we're going to add 40 together, which is 80. 40 plus 40 is 80. And now we're going to subtract 80 from our perimeter 98, and that's going to give us the value of what the width is. So 98 minus 80 is 18. So our width isn't just 18 because we have 2 sides for width here. So we need to divide 18 by 2 now, which is 9. So we know now it is 9. So now we can go ahead and plug in our values for our length and our width and put them into our formula for area. So area equals length times width. We have 40 times 9. I'm not going to do all that mental math here, but we do know that it equals out to 360. So the area of this patio would be 360 feet in total. All right, so now we're going to move on to perimeter, and we're going to incorporate our connecting block manipulatives for perimeter. So let's start with making a rectangle that is 3 squares wide and 7 squares long. One, two, three. me. All right, once I have this here, now I can visually see that the width is 3 and the length is 7. So let's go ahead and count these so we can get our perimeter. So we have 3 right here, we have 3 right here, which we know is 6, and then we have 7 and 7 is 14. So 14 plus 6 equals out to 20. So we know that our perimeter for this rectangle equals out to 20. Well, let's go ahead and let's plug that in with our perimeter formula. So P equals 2 times L plus 2 times W. 2 times L. We know that our length of this is 7. Okay. Show you this. So our formula for perimeter is perimeter equals 2 times length plus 2 times the width. We know that our length was 7 and our width was 3. So 2 times 7 plus 2 times 3. We know 2 times 7 is going to be 14. And we know 2 times 3 is 6. 14 plus 6 together equals 20. We know this to be true because we physically did it with the manipulatives and we could count it and physically see it. And then we also have the visual, or we can also have the visual, but we can take our side lengths and we can plug them into the formula for perimeter. Now let's try doing this with a word problem where we don't have all the information of the side lengths. So let me get this ready here. So what is the perimeter of a garden with an unknown width and a length of 20? The area of the garden is 100. So I'm going to put all the information that I have right here. So since we're solving for perimeter, we're going to put the values that we do have on the outside of the shape because perimeter is about what's on the outside, the distance outside of the shape, around the shape on the outside. Okay, so similar to how we did our last problem, we know that there isn't just 20 because 20 is on both sides because that is the length. So we're looking for the width. So let's add 20 to 20 together. That's going to give us 40. So 100 minus 40 is 60. So now we know that our widths are 60. So let's go ahead. Oh, I had totally messed up. Our widths are not 60. I forgot a step. We need to divide because it's not 60 needs to go on both sides. 60 divided by 2, we now know is 30. And then we can plug in our values here. So now we know that our width is 30 and our length is 20. So let's go ahead and let's plug this into our formula. So we know P equals 2 times length plus 2 times the width. So 2 times the length, which is 20, plus 2 times 30. So we have 2 times 20 is going to be, sorry, I'm getting a little distracted with all the noise. So we know that 2 times 20 is 40, plus 2 times 30, which is 60, which is 100 altogether. So we know that our perimeter here would be 100 altogether for this problem. And it's really important when we're going over how to solve for area and perimeter that we address the possible misconceptions that could be made with this lesson. A lot of times students unfortunately get perimeter and area mixed up because it's very easy to mix up the two. One way I like to make a distinction for area and perimeter is I like to bring up to students that area and perimeter is like a picture frame. So when you look at a picture frame, inside the picture frame is the picture. That is the area, what is inside. Now the frame around the picture frame, that's going to represent our length. Or not our length, I'm so sorry. The picture frame around the picture is what's going to represent perimeter because perimeter is what is outside of the shape. Thank you.